In question 9, I'm asking you to write a square root function that represents each graph. The square root function that we start off with is our parent function, y equals the square root of x, and we're going to see what kind of changes we have made to our parent function graph. So what I do is I locate the ordered pairs of significance, and this is probably the most significant ordered pair that we find. This is the ordered pair -3, 4. So we know that ordered pair is a -3, 4. That ordered pair tells me the translations that we've done. Our translations tell us how far left and right we go or how far up and down we go. So what I know is we have moved this point, and the point that I'm referring to is in our parent function graph. That point is normally at 0, 0. It has been moved 3 units to the left, and it's been moved 4 units up. So I can convert that knowledge into shaping my equation. So y equals, horizontals always happen underneath the radicals, and they're always counterintuitive. So if it goes left 3, we put x plus 3. I also know that the graph was moved up 4, so I put it plus 4. The other thing we have to be careful of is there a vertical transformation. So one of the things we can see very clearly is because this graph is opening downward, that we have to have a negative sign in front of it. So I want to make sure I include a negative here. And now what I want to do is figure out, is there a vertical stretch or not? Now there's a couple of ways of doing this, and one of the ways that I do this is when I know my parent function graph well, then I can figure out transformations well. So typically when we have our ordered pairs for our parent, we have 0, 0 and 1, 1. So that 0, 0 point that I use to figure out the translations, I can also use to help me figure out the stretch. The next ordered pair we put in is 1, 1. So typically when we do our graph goes from 0, 0 to 1, 1. That's our parent, which means when we go right 1, we go up 1. So I want to figure out, when I look at my new graph, what has really happened to it. So when I have my new graph, the transform graph, if I go right 1, I don't want to go up 1 because it's been reflected because of that. So how far down do I have to go until I hit the graph again? So I got to go 1, 2. And when I go 2 places on that graph, I'm already back on the curve. So that tells me I have a stretch of 2. This 2 right here tells me that we have to put in a 2 for our vertical transformation. So it has been stretched twice of what it should be, because typically, I'm just going to repeat myself, but typically when we go right 1, we have to go up 1, and this time we have to go right 1 and go down 2, and the down's coming from the reflection. So there's our transformed square root function, and that would be the conclusion of that problem. We're done.